The Great Pyramid was aligned to true north with an error smaller than a fraction of a single degree. This was no accident, but the result of a profound celestial vision shared by pyramid builders across the ancient world. By the end of this journey, you will understand the forgotten science that allowed empires to build their greatest monuments in perfect harmony with the cosmos. How did cultures separated by oceans and centuries achieve such precision without modern tools? And what secret knowledge was encoded in the stones? What does our own drive to reach for the stars owe to these ancient sky watchers? An astronomer priest stands on a cold desert night, their face tilted toward the infinite blackness. In their hands, a clay tablet captures the timeless dance of the stars. This was the first step in a grand design where a pyramid was not conceived as a mere tomb, but as a perfect echo of the heavens, a sacred machine built to connect the earth to the cosmos. Egyptologists like Dr. Mark Lehner explain that the ancient Egyptians viewed the sky as a divine, orderly realm, a map of eternal truth. To build a pyramid was to replicate that divine order in stone, creating a permanent bridge for the pharaoh's soul to ascend. But how do you translate the chaos of the desert into a perfect square aligned with the four cardinal directions? The answer was written in the stars. The north-south axis was the most critical alignment, and builders found their true north by observing the circumpolar stars. These are the stars that never dip below the horizon, endlessly circling the celestial pole. They were known as the imperishable ones, symbols of eternity itself. By tracking the rising and setting positions of a single circumpolar star, like Kochab in the bowl of the Little Dipper, an astronomer could bisect the angle between its extreme positions to find a fixed, unmoving point in the sky. This was their north. They used a simple but brilliant tool called a Merkhet, a notched palm rib with a plumb line hanging from it. By sighting along the line toward a specific star, a priest could mark a perfectly straight line on the ground. The legendary precision of the Great Pyramid, its sides aligned to true north with an error of just 1/15th of a degree, is a testament to this star-gazing method. It makes you wonder, without lasers or satellites, what profound patience and cosmic understanding did these ancient minds possess? Their achievement was not just architectural, it was philosophical, a declaration that humanity could mirror the heavens here on Earth. That lone astronomer's work was far from over once they found true north. The real challenge began at dawn, translating that celestial marker into a perfect square on the shifting desert sands. They used a tool called a Merkhet, a simple notched palm rib with a weighted string hanging from it. Picture one priest holding this device, sighting along the plumb line to track a star like those in the Big Dipper as it crossed the sky. A second priest stood some distance away, holding a matching sighting tool called a bay. Together, they could mark a perfectly straight north-south line on the ground, a line we call a meridian. This was not a one-night job. As historian Otto Neugebauer explained, this process required clear night after clear night. They had to repeat their observations, averaging out tiny errors caused by atmospheric flicker or human judgment. Each clear night brought them closer to perfection. Once they had their true meridian line established with stakes and cords, the next step was breathtakingly simple yet brilliant. They used the geometry of a circle to create a perfect right angle. From a central point on their north-south line, they would stretch a long, knotted rope, using it to scribe a great circle on the ground. Then they would mark where this circle intersected their original line at 2 points. By connecting these two intersection points with a cord, they created a perfect east-west line, running at a precise 90-degree angle to their celestial north. The base of the pyramid was now defined, a square perfectly oriented to the four cardinal directions, mirroring the order of the cosmos itself. The result of this painstaking stellar method can be seen in the Pyramid of Khufu. Its north-south alignment is off by just 3/60ths of a single degree. To put that in perspective, that is a smaller error than most modern architects would consider significant. It is a staggering achievement, but this makes you wonder what happened on cloudy nights. What did they do when the stars were hidden? This reliance on perfect weather was the method's greatest weakness, forcing these ancient engineers to develop a second, more terrestrial technique for those times when the sky was not their ally. When the stars vanished behind the clouds, the builders turned to a second master in the sky, the sun. On a clear day at Giza, a single vertical rod called a gnomon cast a sharp, dark line across the sand. This simple tool held the key to finding true north without a single star in sight. The method was one of beautiful simplicity. As the sun climbed toward its highest point, the gnomon's shadow grew shorter and shorter. The absolute shortest shadow of the day marked the moment of solar noon, the exact instant the sun crossed the local meridian, directly south in the Egyptian sky. The tip of that shortest shadow pointed unequivocally toward true north. By marking a series of shadow tips throughout the morning and afternoon, an observer could trace a graceful arc. The north-south line was then found by bisecting the angle between two shadow tips of equal length, one from the morning and one from the afternoon. This solar technique was not a replacement for the stellar method, but a powerful partner. Archaeoastronomer Giulio Magli suggests that master builders would have cross-referenced their celestial data, using the sun's reliable path to verify the precise alignments they had painstakingly derived from the stars. This duality of methods reflected the very nature of their world, where the sun god Ra ruled the day and the star-studded goddess Nut enveloped the night. But the sun's role went far beyond just laying out the base. Its annual journey was harnessed for profound symbolic effect. On the equinoxes, when day and night are of equal length, the sun rises due east and sets due west. This celestial symmetry was a powerful anchor for alignment. Some pyramid passages, like those in the Pyramid of Khufu, are thought to be oriented so that the setting sun on the summer or winter solstice would send a beam of light deep into the structure, perhaps symbolizing the pharaoh's soul merging with the cycle of death and rebirth. So how did the interplay between these solar and stellar methods reflect the dual nature of ancient deities? It was a perfect harmony, a testament to a world where earth and sky were inseparable partners in a grand cosmic order. This deep connection to celestial events would become the very blueprint for pyramids far beyond the sands of Egypt. 4,500 years ago, the night sky pivoted around a different anchor. Where our Polaris now sits, a star named Thuban, the brightest in the constellation of Draco the Dragon, held a position of immense power. It was the pole star of the pyramid builders, a nearly fixed point of light circling less than half a degree from the true celestial north. This was not just a navigational aid, it was a cosmic gift. For an astronomer priest sighting with a Merkhet, Thuban provided a singular, almost unmoving target. They could track its path as it made its tight circle around the pole, using its extreme positions to define a perfect meridian line on the earth below. The legendary precision of the Great Pyramid of Giza is a direct result of this celestial partnership with Thuban. Its builders aligned their colossal monument to a star that stood, for them, at the very heart of the turning universe. But the heavens are not static. The Earth wobbles very slowly on its axis over a cycle of 26,000 years, a phenomenon known as the Procession of the Equinoxes. This grand cosmic drift means the position of the pole star gradually changes over centuries, As the pyramids of later pharaohs were built, Thuban was slowly, inexorably, drifting away from its perfect pivot. We can see this celestial migration etched into the stones themselves. Later pyramids, constructed just a few centuries after the Great Pyramid, show slightly greater deviations in their north-south alignment. Their builders were still sighting on Thuban, but their celestial guide was no longer at the true center. This raises a profound question. How did these cultures adapt their sacred blueprints when the very sky they revered began to shift? The alignment was never just about engineering. It was a spiritual act, a way of rooting their kingdom to the eternal order above. When that order appeared to change, it must have demanded both architectural and theological revisions. The silent, drifting stars were actively shaping human history below, pushing empires to refine their methods and reinterpret their connection to the cosmos. This deep, symbolic need to mirror the heavens in stone was a drive that extended far beyond the Nile Valley, compelling other great civilizations to look up and build their own bridges to the stars. The three great pyramids of Giza stand in a line that seems to echo a pattern written in the stars. High above the Nile, the trio of bright stars forming Orion's belt shines with a compelling familiarity. This is the heart of a captivating theory that the entire Giza plateau was designed as a terrestrial map of the cosmos, with the pyramids mirroring the stars of Orion and the great river below representing the vast, shimmering band of the Milky Way. Authors like Robert Bovell have argued that this is no chance arrangement. The relative sizes of the three main pyramids, Khufu, Khafre, and Menkaure, correspond intriguingly to the varying brightness of the three belt stars. Their spatial layout on the ground also mirrors the distinctive, slightly offset alignment of the stars in the sky. For the ancient Egyptians, this connection was deeply spiritual. The constellation of Orion was linked to Osiris, the god of death, resurrection, and the afterlife. To build a pharaoh's tomb as a direct representation of Osiris's stellar home was to create a divine machine for rebirth, a gateway for the king's soul to ascend and join the eternal cycle of the gods. This symbolic intent seems to be reinforced by the very architecture of the Great Pyramid itself. Two narrow shafts, often called air shafts, extend from the king's chamber deep within the pyramid. One of these, the southern shaft, was not for ventilation but for stargazing. During the time of the pyramid's construction, this narrow tunnel was precisely aligned to point directly at the belt of Orion. It was a stellar conduit, a pathway designed to project the pharaoh's spirit straight to the heart of his celestial destination. Yet not all experts are convinced. Astronomers like Ed Krupp point to the slow precession of the Earth's axis, which over millennia changes our view of the stars. The perfect correlation we see today between the pyramids and Orion was not exactly the same 4,500 years ago. The match is close, but was it close enough to prove deliberate intent beyond any doubt? Skeptics suggest the arrangement could be a remarkable coincidence, or perhaps just a general reflection of the Egyptian obsession with the stars, rather than a precise one-to-one map. This leads us to a deeper question. Does the Giza-Orion correlation stand as definitive proof of a master architectural plan, or does it instead reveal a broader cultural pattern, a universal human desire to build our most sacred sites in the reflected light of the heavens? This pattern of celestial mirroring was not unique to Egypt. Far across the world, in the dense jungles of the Americas, another empire was looking up at the same stars and building its own answer to the cosmos. Deep within the sealed chambers of 5th and 6th dynasty pyramids, the stone walls themselves speak of a celestial destiny. These are the pyramid texts, the oldest known religious writings in the world, and they are not merely prayers but direct architectural blueprints for the soul. Carved in hieroglyphs, these spells provide undeniable proof that the pyramids were conceived as cosmic launchpads. They describe, in explicit detail, the deceased pharaoh's transformation and his ascent to join the eternal stars. One powerful utterance proclaims, "A staircase to the sky is set up for me that I may ascend on it to the sky." The destination was often the imperishable circumpolar stars, the very same stars used to align the pyramids to true north. Egyptologist James P. Allen explains that these texts are filled with astronomical references, naming specific constellations like Sar, which we know as Orion, and the Akhet, the horizon where the sun and stars were reborn. The alignment of the pyramid's internal corridors and shafts was not random engineering. It was a physical manifestation of these spells, designed to create a direct pathway for the king's spirit. The southern shaft from the king's chamber, aimed at Orion's belt, becomes a literal fulfillment of a spell that says, "The king is a star who lays the foundation of the horizon." The priests who composed these texts were not just holy men, they were master astronomers interpreting celestial omens and integrating them into the very fabric of the funerary ritual. They ensured that every stone, every angle, and every alignment served this ultimate purpose of astral rebirth. So how did these sacred words directly shape the architect's plans? The texts were the divine instruction manual, demanding that the physical structure facilitate the spiritual journey described within them. This reveals an Egyptian cosmology where the universe was an interconnected whole, where a correctly aligned monument on Earth could trigger a cosmic event in the heavens. This profound literary evidence shows a civilization that thought in celestial terms, a pattern we now see repeated independently on the other side of the globe. Far from the Egyptian desert, the pyramid builders of the Americas looked to a different celestial clock. In the jungles of Mesoamerica, the sacred calendar was not written in the unmoving north, but in the dynamic dance of planets and star clusters. While the Egyptians anchored their world to the circumpolar stars, the Maya and Aztecs charted their destiny by the wanderings of Venus and the glittering ascent of the Pleiades. At Chichen Itza, the Great Pyramid known as El Castillo stands as a masterwork of celestial engineering. Its 4 stairways each have 91 steps, which, combined with the shared platform at the summit, total 365, a direct representation of the solar year. But its true magic reveals itself only on the equinoxes. As the sun sets, the play of light and shadow creates a serpent of shadow slithering down the northern staircase, a phenomenon aligning the earthly structure with the cosmic balance of day and night. This was no vague symbolism, it was precise, predictive science. The Mesoamerican obsession with Venus was particularly intense. They tracked its 584-day cycle with extraordinary accuracy, as scholar Anthony Aveni has detailed, because they saw it as a celestial god, a bringer of both war and rain. Pyramids doubled as observatories, their corners and doorways strategically placed to frame the planet's first appearance as the morning star or its final disappearance as the evening star. This horizon-based astronomy required a different kind of genius. Instead of sighting on a fixed pole, builders would mark a series of wooden stakes along the horizon, noting where a specific star or planet would rise over a distant mountain peak or temple corner over many years. The Pyramid of the Sun at Teotihuacan is a monumental example of this practice. This colossal structure is aligned not to a cardinal direction, but to the point on the horizon where the Pleiades star cluster set directly in line with its peak. For these cultures, the Pleiades, known as the Seven Sisters, held profound agricultural significance. Their annual zenith passage, when they passed directly overhead, signaled the beginning of the rainy season and the time to plant corn, the very sustenance of life. So why did these cultures prioritize such different celestial guides? Their choices reflected the core of their worldview. The Egyptians sought eternal order in the static north, building for the soul's journey after death. The Mesoamericans, in contrast, lived by a cyclical calendar of life, death, and regeneration, intimately tied to agriculture and warfare. Their pyramids were not just tombs, but living clocks that synchronized human ritual with the fertile, and sometimes fearsome, rhythms of the cosmos. This fundamental difference in celestial focus reveals a stunning truth, that the drive to build in harmony with the heavens was a universal human impulse, yet its expression was uniquely shaped by the land, the sky, and the spirit of each civilization. Long before the pyramids of Egypt reached for the stars, the Ziggurats of Mesopotamia were already mapping the heavens. These massive step temples, constructed from sun-baked mud brick, were not just homes for gods like Marduk, but precise astronomical instruments. The great ziggurat of Babylon, known as Etemenanke, was meticulously oriented to the four cardinal directions, an alignment achieved through the sophisticated stargazing of Babylonian priests. These early astronomers were pioneers, compiling detailed star catalogues and developing mathematical models that tracked the movements of planets with remarkable accuracy. As historian Francesca Rochberg explains, their celestial observations were deeply intertwined with their religion, viewing the planets as divine manifestations whose paths held the secrets of fate. To build a ziggurat was to create an axis where heaven and earth met, a sacred mountain whose staircases may have mirrored the sun's own ascent. Their methods for achieving such precise alignments were both ingenious and practical. They used simple tools like the gnomon, a vertical rod whose shadow length could mark the solstices and equinoxes, defining the solar year. They also developed water clocks to measure the passage of time through the night, allowing them to track the steady drift of constellations across the sky. This systematic observation led them to divide the sky into recognizable constellations, many of which we still know today, creating a celestial map that would later influence Greek and Indian astronomy. This knowledge was not kept secret within Mesopotamia. Through bustling trade routes that connected empires, these astronomical concepts traveled, carried by merchants and scholars into Egypt and beyond. The foundational idea that a ruler's monument should be anchored to the cosmos likely spread along these very paths. This raises a profound question. How did the meticulous stargazing of the Babylonians serve as a hidden foundation for the pyramid alignments we see in Egypt and later empires? It suggests a shared pool of celestial knowledge, a slow diffusion of ideas that allowed each culture to build upon the discoveries of the last, all striving toward the same goal of uniting their earthly power with the eternal order of the stars. The celestial knowledge of the pyramid builders did not vanish, it simply migrated west. As empires shifted from the Nile to the Mediterranean, the principle of aligning sacred architecture with the heavens transformed to suit new gods and new philosophies. Greek and Roman temples, while not pyramids, became the new vessels for this ancient science, their alignments now dedicated to solar and planetary deities like Apollo and Jupiter. Historian Alexander Jones points out that Greek astronomers such as Hipparchus did not start from scratch. They built directly upon the meticulous star catalogues and methods inherited from Egypt and Babylon, refining them with their own mathematical genius. This refined knowledge was then etched into the very foundations of their most revered temples. The Romans, ever the practical engineers, adopted these principles with a focus on solar precision. Their temples were frequently oriented to face east, designed to catch the first rays of the rising sun on the statue of the god within, a daily rebirth of divine light. This was more than symbolism, it was a precise astronomical act. At the Temple of Apollo at Delphi, the entrance was aligned so that on specific feast days, the dawn sun would flood directly into the inner sanctuary, illuminating the sacred space at a moment of profound ritual significance. The ultimate Roman expression of this celestial architecture is the Pantheon. Its massive dome, crowned by a single oculus, acts as a colossal gnomon. Throughout the day, the beam of sunlight tracks across the interior, marking the hours and seasons on the marble floor below, a direct and grand echo of the light shafts within the Great Pyramid. This shift from enclosed pyramid to open temple reflects a fundamental change in worldview. Where the pyramids were sealed machines for a king's solitary astral journey, the classical temple was a public stage for communal ritual, where the cosmos was invited to participate directly in human worship. So how did this architectural evolution reflect changing religious and scientific priorities? It signals a move from a secret, priestly science focused on the afterlife to a more public, civic astronomy that sought to harmonize daily life with the visible rhythms of the sun and planets. The drive to build in concert with the cosmos remained, but its purpose had been reimagined for the classical world. While the Egyptians and Mayans built towering monuments, the architects of the Indus Valley forged a different kind of celestial order. In the meticulously planned cities of Mohenjo-Daro and Harappa, the cosmos was not marked by pyramids but by the very layout of life itself. Their streets were laid out in a perfect grid, with entire neighborhoods and major structures aligned almost perfectly to the cardinal directions. This was not a haphazard design. It suggests a society that, like its contemporaries, oriented its world according to a profound understanding of the skies, even if the evidence is more subtle and harder to read. Archaeologist Jonathan Mark Kenoyer points to specific buildings and gateways that seem intentionally positioned. Their alignments may have framed the rising sun on a solstice or highlighted a significant star, turning the entire urban landscape into a vast, open-air observatory. The challenge for modern researchers is the Indus script. These small, intricate seals and inscriptions remain undeciphered, a locked door hiding their precise astronomical knowledge and religious beliefs. Without a royal Rosetta Stone, we are left to piece together their cosmology from the silent geometry of their cities and the patterns of their artifacts. Some intriguing clues have emerged. Certain stones found at sites could have been used as simple sighting devices, their positions marking key celestial events on the horizon. Others have theorized that the civilization's sophisticated water channels and reservoirs were more than just practical. The still surfaces of these pools could have been used to reflect the night sky, creating a stable, earthly canvas for mapping the stars, a practice seen in other ancient cultures. The Great Bath at Mohenjo-Daro stands as a powerful example. This large, waterproof tank central to the city may have served a ritual purpose far beyond bathing. Its precise orientation and elevated position evoke the sacred Ziggurats of Mesopotamia, a civilization with which the Indus people actively traded. This exchange of goods almost certainly included an exchange of ideas, including foundational concepts of astronomy and urban planning rooted in celestial order. So what profound secrets about humanity's universal drive to mirror the heavens are still trapped within those undeciphered symbols? The Indus Valley civilization presents a compelling mystery, a reminder that the quest to build in harmony with the cosmos was a global phenomenon, expressed not only in towering stone but in the very streets where people lived and looked up at the stars. Across the world, the earthen pyramids of China rose in silent testament to a different celestial order. Nestled in the Xi'an region, these massive, grass-covered mounds were the final resting places of emperors, and their alignments reveal a cosmology deeply interwoven with the stars. While the Egyptians built with geometric precision in stone, the Chinese masters shaped the very earth itself, aligning their tombs to the cardinal directions with a profound emphasis on the northern pole. The Big Dipper held immense imperial significance, seen not just as a constellation but as the celestial chariot of the emperor, governing time and the seasons. This was more than astronomy, it was the practice of feng shui on a grand scale, a sacred geomancy that sought perfect harmony between the earthly landscape, the buried tomb, and the overarching dome of the sky. Scholars like David Pankania highlight how Chinese court astronomers maintained impeccable records of celestial events, viewing comets and planetary conjunctions as direct messages from heaven that could legitimize or undermine a ruler's mandate. To translate this cosmic vision into architectural reality, they employed sophisticated tools. The gnomon, a simple vertical pole, was used to determine the solstices and mark true north by tracking the sun's shadow. For more complex calculations, they developed the armillary sphere, an intricate bronze model of the heavens with rings representing the celestial equator and the path of the sun. This device allowed them to map the motions of the stars with stunning accuracy, ensuring their imperial pyramids were anchored to the correct celestial coordinates. The mausoleum of the first Qin emperor, guarded by his terracotta army, is a monumental example. While its exact stellar alignments are less studied, the entire complex is believed to be a microcosm of his empire, with its orientation likely reflecting his quest to rule an immortal dynasty from the afterlife, perfectly synchronized with the eternal northern stars. So how did these Eastern alignment practices differ from those in the West? The Chinese methods were not just about a soul's journey to the stars, but about creating a permanent, earthly seat of power that was in constant, correct relationship with the cosmic order. It emphasized continuity, stability, and the emperor's role as the central pivot between heaven and earth, a cultural value that saw the cosmos as a single, interconnected system of rule. This Eastern perspective completes our global picture, proving that the drive to build in concert with the heavens was a universal language, spoken in as many dialects as there were empires under the stars. South of Egypt, along the Nile in modern Sudan, the Kushite kingdom built their own answer to the pyramids. These Nubian structures are instantly recognizable, smaller and far steeper than their Egyptian predecessors, with a sharp, dramatic angle that gives them a unique silhouette against the desert sky. The Kushites were not mere copycats. They adopted the core principles of Egyptian celestial alignment, but then they adapted them, weaving in their own distinct star lore and solar beliefs to create a sacred architecture that was entirely their own. At sites like Meroe, dozens of these pyramids stand in neat rows, their bases carefully oriented to the cardinal directions. Archaeologists such as Laszlo Turek have studied these sites extensively, finding that the builders almost certainly used familiar tools like the Merkhet. Yet they added their own signature elements, most notably the capstones that crowned each pyramid. Where the Egyptians often used a polished stone pyramidion, the Nubians designed capstones that were themselves precisely aligned, perhaps to point toward a specific, significant star in their cosmology. This subtle shift highlights a crucial adaptation. The relentless procession of the equinoxes meant the sky over Nubia was not exactly the same as it had been over Old Kingdom Egypt centuries before. The pole star had drifted, and the Kushite astronomers had to adjust their sighting methods accordingly, updating the sacred blueprints to match their contemporary heavens. This celestial revision was also shaped by history. The region had experienced periods of Egyptian colonization, and with that contact came a transfer of knowledge, the foundational techniques for finding true north and laying out a perfect square. But once that knowledge was absorbed, the Kushites made it their own. You can see this independence in the very entrances to their pyramids. While Egyptian pyramids often emphasized the north-south axis for the soul's stellar journey, many Nubian pyramids have their entrances facing directly east, designed to catch the first rays of the rising sun. This suggests a powerful solar cult where daily rebirth was celebrated in a beam of dawn light entering the tomb. So what can these Nubian adaptations teach us about the spread of celestial knowledge? They show that the science of aligning monuments was not a rigid dogma, but a living tradition. As it traveled across Africa, it was filtered through local beliefs, proving that the universal human drive to connect with the cosmos could inspire an endless variety of architectural expressions, each one perfectly tuned to its own culture and its own sky. This mathematical precision required a simple yet brilliant tool, the Seked. The Seked was the ancient Egyptian unit for the slope of a pyramid side, defined as the horizontal distance in palms for a vertical drop of 1 cubit. Think of it as the ancient blueprint for the perfect angle. A master builder would not simply guess the incline, they would calculate it using this standardized ratio, ensuring that every single block laid would contribute to the grand, smooth plane pointing toward the heavens. This mathematical control over the slope was absolutely critical for alignment. A pyramid with uneven or miscalculated sides would have its corners pointing in the wrong directions, throwing off the entire celestial connection its builders worked so hard to achieve. The Seked provided the consistent geometric rule that translated their celestial observations into an immovable mountain of stone. Even more astonishing are the mathematical constants seemingly encoded within the Great Pyramid's very shape. The renowned Egyptologist Flinders Petrie's meticulous surveys revealed that the ratio of the pyramid's perimeter to its height is extremely close to 2 pi, the mathematical constant relating a circle's circumference to its diameter. This suggests the builders may have been symbolically squaring the circle, representing the spherical heavens within a square, earthly plan. How did they achieve this with such rudimentary tools? The answer lies in a practical, rolling measurement. They likely used a wheel of a known diameter, rolling it along the base to measure a straight line and then comparing that length to the vertical height. This simple mechanical action could embed the profound relationship of pi directly into the monument's proportions. This mathematical genius extended to the foundational layout. The builders used ropes to create perfect right angles, likely employing what we now call Pythagorean triples, sets of 3 whole numbers that perfectly satisfy the famous theorem for a right-angled triangle. They used these triples like a 3-4-5 triangle centuries before the Greek philosopher was born to ensure their corners were perfectly square and their diagonals true. So how did this abstract math, calculated on papyrus with simple fractions, become a physical reality spanning 13 acres? It was a system of checks and balances where geometric theory was constantly verified against the stars themselves. The mathematical blueprint and the celestial map were 2 parts of a single, unified vision, a testament to an innovation that saw numbers not as abstract symbols, but as the very language of the cosmos. The sheer weight of a single pyramid block could crush any hope of celestial alignment if its placement was even slightly off. Thousands of workers hauling stones heavier than elephants faced an immense logistical puzzle. How do you move a 2-ton block of limestone from a distant quarry and set it into a structure that must remain perfect to a fraction of a degree over decades of construction? The answer was a symphony of brute force and delicate precision. Engineers like Craig B. Smith have analyzed the construction, revealing that before a single stone was laid, the foundation itself had to be flawlessly level across an area of 13 acres. They achieved this not with lasers but with water. Workers dug a grid of shallow trenches across the bedrock, filling them with water to create a perfectly flat plane. By measuring down from the water's surface, they could chip the bedrock down to a uniform level, creating a base as true as a still pond. This level foundation was the non-negotiable first step, the stable canvas upon which their celestial map would be drawn. But the true test came with the ascent. Massive ramps built of earth and rubble spiraled or ran straight up the growing pyramid. Workers dragged stone blocks on wooden sledges, a method depicted in tomb paintings. These ramps were not just piles of dirt, they were carefully engineered structures, their own alignments constantly checked against the original meridian lines staked out on the desert floor. A sledge path that drifted even a hand's breadth off course over hundreds of feet would spell disaster for the final alignment. The logistics were staggering. Each casing stone, especially the brilliant white Chora limestone for the outer layer, had to be quarried to a specific angle and size. These stones were not just building material, they were optical instruments. Their final polish was so fine that the completed Great Pyramid would have gleamed like a faceted jewel under the Egyptian sun, a man-made star visible for miles. This reflective surface was not merely for show. It may have served a ceremonial purpose, catching the first or last light of the sun to signal an equinox, or perhaps even reflecting the pale light of the imperishable stars it was aligned to, a beacon connecting earth and sky. So what kind of society could organize such a monumental effort? It required more than just slave labor. It demanded a permanent, skilled workforce of quarrymen, engineers, and astronomers working in concert for generations. This was the ultimate expression of cosmic ambition, where the sweat of thousands and the patience of decades were offered up to achieve a perfection that would literally touch the stars. For a pharaoh, the first stone of a pyramid was more than a foundation. It was a declaration of divine authority. This was not architecture for the living, but a sacred machine designed to channel cosmic power and secure immortality. Every precise alignment was a prayer in stone, a physical assertion that the king was the linchpin holding the universe in balance. Egyptologist Jan Usman explains this principle as Ma'at, the fundamental order of the cosmos that the pharaoh was duty-bound to uphold. By building a structure that mirrored the perfect, unchanging circuits of the stars, he was actively reinforcing this balance, proving his right to rule not just Egypt, but as a partner to the gods themselves. The pyramid was his conduit, a permanent bridge for his soul to ascend and join the imperishable circumpolar stars, those eternal lights that never fell below the horizon. This celestial symbolism was meticulously tailored, with different stars representing specific deities and myths central to a dynasty's identity. The star Sirius, known as Sopdet, was intimately linked to the goddess Isis. Its annual heliacal rising, its first appearance just before the dawn, heralded the life-giving flood of the Nile. A pyramid aligned to this event connected the pharaoh to the cycle of death and rebirth, and to the very fertility of his kingdom. This was celestial propaganda, a demonstration for all to see that the king possessed mastery over the forces of nature itself. A powerful illustration of this is the Great Sphinx at Giza. On the equinox, the rising sun aligns perfectly between the two great pyramids behind it, framing the Sphinx, a representation of the pharaoh as the sun god Horus. In that moment, the king is literally reborn with the sun, his power fused with the cosmic balance of equal day and night. So how did this profound symbolism actually drive technological innovation? The spiritual need for perfect alignment demanded ever more precise tools and methods. The desire to perfectly mirror the heavens forced engineers to develop new mathematics, new surveying techniques, and a new understanding of the sky. The sacred goal was the engine of their scientific progress, pushing human capability to its limits in service of a cosmic vision. The astronomer's toolkit held far more than a single notched palm rib. In the dim light of a desert workshop, a collection of specialized instruments awaited the night's work, each designed to refine the cosmic connection etched in stone. Alongside the essential Merkhet lay its partner, the bay, a sighting tool with a narrow vertical slit that allowed a priest to pinpoint a single star with remarkable precision. But tracking a star's position was only half the battle. Knowing the exact time was equally critical. For this, they turned to the clepsydra, or water clock. This device, often a stone vessel with a small hole, measured the passage of time through the steady drip of water, allowing observers to log a star's transit across the meridian at the same precise moment night after night. This systematic timing was the key to averaging out tiny observational errors, pushing their accuracy from impressive to nearly perfect. Experts like Juan Antonio Belmont suggest the true genius lay in combining these methods. A master builder would not rely on stars alone. He would use the sun's dependable path as a celestial check, employing a simple gnomon to mark solar noon and verify the true north-south line derived from nighttime observations. This cross-referencing of solar and stellar data created a self-correcting system, a feedback loop of cosmic information that continuously refined their alignments. As this knowledge traveled across empires, the tools themselves evolved. The Greeks later introduced the dioptra, a sophisticated theodolite for measuring horizontal and vertical angles with a degree of precision that would have astounded the earliest pyramid builders. One of the most evocative theories involves the use of reflected light. On a night when the horizon was hazy, an astronomer might use a polished copper mirror or the still, dark surface of a ceremonial pool to capture the shimmering image of a circumpolar star. By observing this reflection, they could stabilize the star's often flickering appearance, creating a clearer, steadier reference point for their alignment lines. But what were the inherent limitations of this ancient technology? Even the most skilled observer was at the mercy of atmospheric turbulence, the very air itself bending starlight and introducing minute errors. They compensated not with better optics, but with relentless patience and statistical genius, repeating their measurements over hundreds of nights to let the random errors cancel each other out. This entire toolkit, from the humble water clock to the imagined reflective pool, highlights a profound ingenuity, a relentless drive to use every resource available to capture the perfect order of the heavens and translate it into the immutable language of stone. That slow celestial drift meant the sky was a moving target. The Earth's axis wobbles over a grand cycle of 26,000 years, a phenomenon we call the precession of the equinoxes. This imperceptible shift, like the slow breathing of the cosmos, gradually changes our view of the stars. The pole star of one millennium becomes a wanderer in the next. For the pyramid builders who had anchored their entire sacred architecture to a seemingly fixed sky, this presented a profound and creeping challenge. A star like Thuban, which was a brilliant guide for the great pyramids builders, had drifted noticeably away from true north just a few centuries later. We can see this celestial migration literally set in stone. Later pyramids, like those built during the Middle Kingdom, show slightly greater deviations in their north-south alignment. Their builders were still using the same meticulous methods, still sighting on the circumpolar stars, but their celestial reference points were no longer where they used to be. This was not a failure of engineering, but a consequence of cosmic motion. How did these cultures, with no concept of a 26,000-year cycle, perceive such a gradual change? They likely did not understand the mechanics of axial precession, but their meticulous records of star positions over generations would have revealed an undeniable truth: the heavens themselves were slowly shifting. This empirical observation, this long-term data collection, forced both architectural and theological revisions. The Greek astronomer Hipparchus is often credited with formally documenting precession around 130 BC, but the evidence suggests the Egyptians were living with its consequences for over 1,000 years. The decline in the pinpoint precision of later pyramids might not reflect a loss of knowledge, but a necessary adaptation to a dynamic cosmos. They were not building for a static sky, but for a living, breathing universe that demanded their sacred blueprints evolve. This raises a deeper question about their worldview. When the very stars you worship begin to drift from their appointed places, how do you reconcile that with a belief in eternal, divine order? The answer may lie in revised myths, in new interpretations of the gods' journeys, and in a resilient understanding that even the heavens were part of a grand, slow cycle of change and renewal. Even the most skilled astronomer priest could not command the clouds. A sudden sandstorm, a bank of thick seasonal fog, these were forces beyond any sacred blueprint, erasing the stars for nights on end and halting the entire celestial surveying process. The ancient builders operated under a pressing, practical constraint. They needed an unbroken series of perfectly clear nights to refine their alignments to that legendary precision. A single week of overcast skies could introduce frustrating delays, while a season of poor weather might force a team to proceed with their best available data, introducing tiny, permanent errors into the foundation. The landscape itself presented its own obstacles. An ideal observation point required a long, flat, and unobstructed view of the northern horizon. A rogue dune, a rock outcrop, or even the growing bulk of a neighboring pyramid could disrupt the clean sightline needed to track a circumpolar star like Thuban. Egyptologist Kate Spence highlights how such environmental pressures inevitably led to slight deviations. The most famous example is the bent pyramid at Dosha, its upper section built at a shallower angle than its base. This dramatic change in plan is often attributed to structural concerns, but it also speaks to the challenges of maintaining perfect celestial alignment over a decades-long project, where the original master surveyor might not live to see its completion. Human error was an ever-present specter. A tired priest might misjudge the exact moment a star crossed his Merkhet's plumb line. A stretched measuring cord worn by the desert sun could shrink or expand by a few critical fingers' breadth over a long distance. These minute mistakes, compounded over a foundation 13 acres wide, resulted in the subtle variations we can still measure today. The pyramids at Giza, for all their collective glory, do not possess identical alignments. The Pyramid of Khafre is slightly, yet detectably, less perfect in its orientation than the Great Pyramid of his father, Khufu. This variation is a silent testament to different construction teams working under different conditions, or perhaps to the accumulated experience or inexperience of a new generation of builders. So how did they fight back against these inevitable imperfections? Their greatest weapon was redundancy. They did not rely on a single observation or a single team. Multiple groups of priests would make independent measurements from different vantage points, and their results would be compared and averaged. They also used secondary alignments, constantly checking their work against the sun's path or the rising of other key stars like Sirius. If a primary stellar line seemed off, they could use these terrestrial and solar markers to correct the course. What can these ancient imperfections teach us? They reveal the beating human heart behind this cosmic science. The pyramids were not magically perfect. They were human achievements, forged in the gritty reality of desert storms, aching muscles, and the fallible judgment of even the most devoted eyes. Acknowledging their struggles does not diminish their glory. It grounds our awe in the tangible, reminding us that their greatest triumph was overcoming the chaos of the world to touch the order of the stars. The Great Pyramid stands as the ultimate expression of a celestial vision carved in limestone. Its four sides are aligned to the cardinal directions with an error of just 3 arc minutes, a deviation smaller than the width of your thumb seen from the length of a football field. This was not the work of a single method, but the culmination of a symphony of techniques perfected over generations. Master builders began with the stars, using the Merkhet to painstakingly track the circumpolar stars like Thuban, establishing a true north-south meridian line across the Giza plateau. This celestial baseline was then verified and refined using the sun, with gnomons marking solar noon to cross-check the alignment derived from the night sky. The result was a foundation so true that the structure itself became a terrestrial pole, but the pyramid's connection to the cosmos extends far beyond its base. Deep within its heart, two narrow shafts angle upward from the king's chamber, one aimed directly at the belt of Orion, the constellation of Osiris. Another shaft from the queen's chamber targets the star Sirius, linked to the goddess Isis. These were not air vents, but spiritual conduits, designed to channel the soul of the pharaoh directly to the specific celestial realms of these deities. The precision does not stop with astronomy. The pyramid's very geometry seems to encode fundamental mathematical constants. The ratio of its perimeter to its original height is remarkably close to 2 pi, suggesting the builders were symbolically squaring the circle, representing the spherical heavens within a square, earthly plan. Authors like Robert Bovell see this as part of a grand design, a cosmic clock or a gateway frozen in stone, its alignments capturing a specific moment in the precessional cycle. Graham Hancock and others have proposed that such precision implies a lost wisdom, perhaps from a civilization even older than dynastic Egypt. So, does the Great Pyramid represent the absolute peak of ancient alignment technology, a secret now lost to time? Or does its enduring mystery hint that we have only begun to decode the full scope of its builder's knowledge? This single structure encapsulates the entire journey, from the desert astronomer's first stargazing to the final, polished stone pointing to the imperishable stars. A shared celestial language flowed along the ancient world's trade routes, whispered between merchants and decoded by multilingual scholars. This was not a secret kept by one empire, but a body of knowledge passed like a precious commodity from Babylon to Egypt, and from Egypt to the rising powers of Greece and Rome. The movement of astronomical techniques was driven by more than just curiosity. It was propelled by conquest, diplomacy, and the sheer practical need to navigate and govern. When the Hyksos, a Semitic-speaking people from the Levant, established themselves in the Nile Delta, they did not arrive empty-handed. They brought with them advanced technologies of war and almost certainly the sophisticated stargazing traditions of their homeland, which then intermingled with established Egyptian practices. Centuries later, the campaigns of Alexander the Great tore down cultural barriers, deliberately blending the celestial knowledge of the East with the emerging scientific philosophy of the West. His generals founded cities like Alexandria in Egypt, which became a melting pot where Babylonian star catalogues, written in cuneiform on clay tablets, were translated and studied alongside Greek geometry. Historian David King points to the critical role of these multilingual scholars, men who could read the stars in multiple languages, preserving the core methods like gnomon use and meridian observation while adapting them to new cultural context. This was not a one-way street. The foundational idea that a ruler's power was legitimized by aligning his monuments with the cosmos proved irresistibly powerful, a political and spiritual technology that was adopted and adapted by every aspiring empire. It is this pattern of diffusion that makes the curious similarities between Egypt and the Maya so tantalizing. Both built pyramids aligned to cardinal directions and significant stars, yet they were separated by an ocean. This suggests a profound universality, a shared human instinct to look up at the same sky and seek order, whether the knowledge traveled or was independently born from the same celestial inspiration. How did this silent, global collaboration across millennia fundamentally shape the trajectory of science itself? It reveals that our modern understanding of the universe was not invented in a single place, but was pieced together over centuries, a collaborative human project whose first architects were the pyramid builders gazing at the imperishable stars. The same desert winds that once whispered to ancient astronomers now carry the hum of drones. Inside a modern laboratory, the ghostly point cloud of a laser scan reconstructs a pyramid down to the millimeter, revealing alignments invisible to the human eye for millennia. This is the power of archaeoastronomy, a field that bridges the gap between celestial myth and hard data. Pioneers like Gerald Hawkins were among the first to turn computers toward the past, using them to simulate the night sky as it was 4,000 years ago. His digital reconstructions confirmed that alignments once dismissed as coincidence were, in fact, deliberate, proving that celestial events were the true blueprints for these monuments. Today, the tools are even more extraordinary. Light detection and ranging, or LiDAR, uses lasers fired from aircraft to pierce dense forest canopies, mapping entire ceremonial landscapes. Archaeologists have used this technology to discover that pyramids in Guatemala are aligned not in isolation, but as part of a vast, interconnected grid of temples and roads, all oriented to key solar and stellar events. Back in Egypt, high-resolution drone photography captures the subtlest shifts in a pyramid's orientation across its base, shifts that tell a story of construction phased over years, each phase checked against a slowly processing sky. Researchers like Juan Antonio Belmont use this data to test theories without ever touching a stone, preserving the monuments while decoding their secrets. A stunning example comes from the bent pyramid at Dosha. For centuries, its strange double angle was thought to be a panicked correction to prevent collapse. But recent scans suggest a more celestial reason. The lower slope may have been aligned to the star Thuban at a specific point in its precessional journey, while the upper, shallower slope targeted a different, significant star. This was not a mistake, but a deliberate recalibration, a change of sacred plans written in the shifting sky. As our technology grows more sensitive, what other long-held assumptions about these ancient builders will be overturned? The silent stones have been holding their secrets, waiting for us to develop the right questions and the right tools to hear their answers. The legend of a lost super-civilization or extraterrestrial architects is a compelling story, but it crumbles under the weight of actual evidence. These myths often share a common flaw. They strip ancient people of their own genius, suggesting they could not have achieved such marvels without outside help. Renowned Egyptologist Zahi Hawass has spent decades confronting these claims, consistently pointing to the mountains of archaeological proof, from workers' villages and quarries to the trial and error constructions like the bent pyramid, which show a clear and human evolution of engineering. The precision of the pyramids was not a gift from the stars, but the hard-won result of generations of sustained observation, meticulous record-keeping, and painstaking refinement. Consider the so-called Orion correlation theory. While the symbolic link between the Giza pyramids and the stars of Orion's belt is culturally plausible, the theory often claims a perfect, one-to-one match frozen in time. This ignores the slow precession of the equinoxes, which means the celestial alignment we see today was not exactly the same when the pyramids were built. The match is evocative, not photorealistic, reflecting a general spiritual intent rather than a geodetic blueprint from Atlantis. The idea of pyramids as power plants is another persistent fiction. Proponents point to the materials like the quartz-rich granite in the king's chamber, suggesting it could generate piezoelectricity. Yet this ignores the complete absence of any wiring, turbines, or a single shred of evidence that the Egyptians had any concept or use for electrical power. Every artifact and text we have points to a single, overwhelming purpose. These were sacred tombs designed for a pharaoh's rebirth, not primitive generators. So why do these captivating myths hold such power over our modern imagination? They speak to our own sense of wonder and perhaps a discomfort with the sheer scale of human patience and collective effort. It can be easier to believe in a single, vanished advanced race than to accept that thousands of ordinary people, through simple tools and relentless dedication, could achieve something so extraordinary. Embracing the truth does not diminish the pyramids, it elevates them. They stand not as mysterious relics of a forgotten technology, but as timeless monuments to what humanity can accomplish when we look to the stars with patience, purpose, and our own innate intelligence. The principles that align the pyramids now shape our modern skyline. Architects and city planners are rediscovering the ancient wisdom of celestial orientation, using it not for pharaohs' tombs, but for sustainable buildings and meaningful public spaces. This is not about copying old forms, but about reviving a profound connection between our structures and the cosmos. The French architect I.M. Pei did not merely replicate a shape when he designed the glass pyramid for the Louvre in Paris. He invoked the same timeless geometry and precise alignment, creating a modern gateway that, like its Egyptian predecessors, plays with light and perspective, anchoring a vast complex to the cardinal directions. Similarly, the Washington Monument in the United States stands as a towering obelisk, its very form a nod to ancient Egypt. Its alignment is so exact that on certain nights, the pole star Polaris can be seen directly in line with its peak, a silent tribute to the same celestial north that guided the builders at Giza. This is more than homage, it is the continuation of a design philosophy where architecture serves as a bridge between earth and sky. Visionary architects like Norman Foster explicitly harness this ancient knowledge. His firm designs buildings that follow the sun's path, using sophisticated glass and shading systems to maximize natural light and minimize energy consumption. This modern solar alignment is the direct descendant of the Nomen's shadow on the desert sand, a high-tech application of the same principle that balanced light and shadow for the pyramid builders. Entire cities are being planned with this celestial logic. New urban developments sometimes lay out their main thoroughfares to align with the sunrise on the summer solstice, flooding the streets with light on the longest day of the year. This recreates the communal experience of a solar event, turning a city grid into a vast public solar calendar. Artists are also reviving sacred geometry, incorporating the golden ratio and pi into sculptures and installations that evoke a subconscious sense of harmony, the same mathematical order found in the Great Pyramid's proportions. In an era defined by climate change, this ancient wisdom offers a powerful blueprint. How can we design our future cities if we once again see ourselves as part of a larger cosmic order, building in concert with the sun, the stars, and the very rotation of the planet? The legacy of the pyramids challenges us to look up not just for inspiration but for direction. The silent stones of Giza may yet share their deepest secrets, not with shovels but with satellites. Pioneering archaeologists like Sarah Parcak are now using infrared imaging from space to peer beneath the sands of Sudan and the dense canopies of the Americas, revealing the ghostly outlines of pyramids and settlements we never knew existed. These potential sites, hidden for millennia, promise to reshape our entire map of ancient celestial ambition. The future of pyramid studies lies in this interdisciplinary fusion, where computer scientists train artificial intelligence to detect subtle alignment patterns across thousands of monuments, patterns far too complex for the human eye to ever discern. Imagine an algorithm comparing the orientation of every known pyramid, from the Nile to the Yucatan, searching for a common celestial language we have yet to decipher. Current research is also diving into literal uncharted waters, with marine archaeologists exploring submerged sites that could hold the key to understanding how coastal cultures align their structures with the horizon over the open ocean. But some of the most profound questions are not about where to dig, but how we interpret the society behind the stones. What was the exact role of women in these precise astronomical observations? Were they priestesses, record keepers, or perhaps the master surveyors whose contributions have been erased by time? The debate still rages over the purpose of the narrow shafts within the Great Pyramid. Were they solely spiritual conduits for the king's soul, or did they serve a more precise function as targeting scopes for specific stars on specific dates, a celestial calendar frozen in limestone? As we refine our dating methods with atomic precision, we can now pinpoint the exact year a pyramid's cornerstone was laid, allowing us to recreate the night sky with flawless accuracy and finally test long-held theories about stellar alignments. With every technological leap, we are granted a clearer lens into the ancient mind. What breathtaking breakthroughs will the next decade reveal, and what long silent voices from the past will we finally learn to hear? Our journey across empires and epochs reveals a stunning truth, that the drive to build in harmony with the cosmos is a universal signature of humanity itself. From the Egyptian priest citing Thuban with a simple Merkhet to the Mayan astronomer timing the descent of the feathered serpent, we see the same story written in stone, a story where science, faith, and art were inseparable strands of a single cosmic vision. These builders were not primitive, they were pioneers, using the gnommon's shadow and the star's transit to anchor their greatest monuments to the eternal turn of the heavens. They looked up at the same sky we see tonight and saw not random points of light, but a divine order they were compelled to mirror on Earth. The legacy they left is far more than a collection of silent tombs. It is a vibrant testament to a shared human quest for meaning, a quest that transcended oceans and centuries. The next time you find yourself under a clear night sky, look up, see the constellations of Orion and the Big Dipper, the same celestial guides that inspired the blueprints of empires. Let that connection sink in, a thread of ingenuity that binds you to every ancient soul who ever gazed upward in wonder. We would love to hear which part of this celestial journey captivated you most, so please share your thoughts in the comments below. If exploring history's greatest mysteries lights a fire in you, subscribe to keep the journey alive.